Hello everyone, and today we will be tackling this harder list challenges, starting from 7A and hopefully ending on 7D. Now, these challenges are much trickier than everything we've seen before, so you might want to, during this video, pause it and reflect on why some of this code works before moving on. I'll try and explain it in as much detail as possible, but I also have another challenge for you. Even though these problems are hard, and also for the subsequent ones, I believe that every problem in this REPL can be solved using less than 10 lines of code. And I would challenge you to try and figure out how to code all of these problems as efficiently as possible before watching my video, and when I'll show you what I think the best solution is for these problems. So let's start on 7A. Pairs of equal numbers. We're given a list of numbers and we want to count the number of pairs of equal elements. Any two elements that are equal to each other should be counted exactly once. Right. So we can see here that we have 1, 2, 3, 2, 3. And these two 2's are a pair. These three 3's are a pair, so it's 2. In this case, we have 1, 1, 1, 1, 1, and it's outputting 10. And that's because the first number is pairs with the second, third, fourth, and fifth. The second number, we won't count that. It's paired with the first, but we won't count that because we're only counting pairs once. So it's paired with the third, fourth, fifth. The third number is paired with the fourth and fifth, and the fourth number is paired with the fifth. So that gives us 4 plus 3 plus 2 plus 1, which we know is 10. So that's why the output is 10. So how are we going to solve this problem? To solve this problem, we want to use 2 for loops this time and really loop over the list twice. So let's have our input as a list, and we want to also have a count of the number of pairs, which we'll set to 0 at the very start. So what our first for loop is going to do is it's just going to loop through every number one by one. So for for number 1 in L, let's just say that. And we can cheat a little by slicing off the last element from the list because it's not needed. There's no pair that can come from after the last number, and if the last number was pairs of any of the numbers before it, we'll count it in our second for loop. So what this second for loop is going to do is it's going to loop through every number that's after our current number here. So actually we need to use it enumerate on the first for loop just so we know where our index is right now. So for I, number 1, and enumerate this. So for example, our first for loop, the first number we'll get is 1. And in our second for loop, we want it to loop through every number after that 1, check if it's equal to this number, and if it is, we can add 1 to the number of pairs. So we can use for number 2 in L, and we want to start at the index we're currently at, plus 1. And we want to end at the end of the list. So we're counting all of the numbers. And finally, we want to check if number 1 is equal to number 2, then we want to add 1 to the count. So count plus equals 1. And finally, we want to print this count, which is the number of pairs. So if we print this, it should give us the correct count. So let's test it for the example input. Copy that. We run the code. If we input these numbers, then, as you see, we get 2. Now, let's test it for the second input. So as you can see, it should count 4 plus 3 plus 2 plus 1 pairs. Let's see if it does that. Sorry, run again. And as you can see, it counts those correctly. So Currently, that's 7 lines of code. So we've done this problem in under 10 lines of code. So let's submit it. And as you can see, we've got everything right. So let's move on to the next challenge. Okay, now we're on our second challenge. We are given a list of numbers. We want to find and print the elements that appear in it only once. Such elements should be printed in the order which they occur in their original list. Okay, so in our example input, we have 43525 and our output is 421. So as you can see, because the 3's and the 5's are repeated, we don't want to count them. We only want to count the elements that appear once. Right. Okay. So to do this, we're actually going to need to use 2 more lists on top of this first list. Let's call the first this L. And in our first list, we want to make a list of all the elements we've seen once. So seen once is equal to nothing. And we want to also make another list for elements where we've seen them more than once. So seen more is equal to an empty list. And so what we want to do is we want to loop through our example input and have some logic. So if we haven't seen a number, we want to add it to the seen once, because now we've seen it just once. And if we have seen a number already, then we want to add it to the seen more and remove it from the seen once, since now we've seen it more than once. To do this, we can first make a loop for element in L, and then let's first check if the element is in seen once. So if element in seen once, which means we have already seen the element at least once. Oh, sorry, if we've only seen the element once, then we want to add it to the seen more. So seen once dot pop, and this is how we can remove an element from an array element, and we want to add it to seen more. So seen more dot append, which if you remember is how we add elements to an array, and then we have element. Otherwise, we want to check if we haven't seen the element in once. And if we haven't, we want to add it to this list. So elif seen once, element really not in seen more. So not element in seen more. So just checking, this already checks if we've seen it once. So if it's not in the seen more, it means we haven't seen the element at all. In this case, we want to append the element to the seen once list. And our third case is if we've already seen the element more than one time. In that case, we don't have to do anything, because if we've already seen it more than once, it's already in the seen more list, and therefore we're not going to print it already, and our code already knows how to check whether it's seen the element. Finally, we can print our seen once list, which is the elements that appear only once, and that should give the correct answer. So let's test it for this example input. We run the code. Pop index out of range. Oopsies, I forgot. So we want to actually remove this element. Sorry, so we want to use the method remove, which removes the element, not pop. Pop is used to remove an element at an index. Remove is used to remove an instance of an element. So if we run this code, taking the example input, it gives us the correct output, as we can see. And we are also within 10 lines of code. How convenient. So if we submit this code, as you can see, it's working perfectly. Now, on to the next problem. 8 queens. So Is it possible to place 8 queens on an 8x8 chessboard so no 2 queens threaten each other? So no 2 queens share the same row, column, or diagonal. So we're given a placement, and if there are a pair of queens that violates the rules, so in other words, they can attack each other, we want to print yes, otherwise we print no. And let's see what our input is. Input is 8 coordinate pairs, 1 per line, with each pair giving the position of a queen on a standard chessboard. Okay, cool. So we first, sorry about that. Let's first import these lists. And I'm gonna do something custom about this. We already know we're only going to have 8 queens. I mean, 9 queens I think it's impossible. So in this case, we know that we want to input our stuff for I in range 8. In this case, I is doing nothing. It's just the fact that we're looping through this 8 times, and therefore we're going to get all 8 inputs. However, I also want to convert these inputs already into numbers. And how are we going to do that? Well, we're going to first split the input inside here. Sorry about that. Let me just close this. We're going to split the input here, and then we're going to loop through this and make each element of this input.split an integer. So int number for number in input.split for I in range 8. And what this is going to do is this is going to import our just moving myself up here. Sorry about those notifications. What this is going to do is it's going to convert all of our numbers into numbers from the input, and it's going to do that 8 times and add that all into an array. So what does this actually do? So let me show you what this results in if we input it like this. So let's run our code and let's copy down this example input, paste it all here, and interesting. Input.split for I in range 8. Oh, that's a bit odd. I think I've done this the wrong way around. So let me just sorry, I forgot to put square brackets here. So what I was actually doing was some other version of the code. But what I actually wanted to do, hopefully we can see it now, is that it now takes in the coordinate pairs and puts them into lists inside this larger list. So the first square bracket on our list is going to be which queen we want. So say we want the 0th queen, and we input all of this. It's going to give us 1, 5 back. And so we want to use another square bracket to access the second layer of this list. This is called a 2D list, and we'll cover it in later detail when some challenges come up about it. So if we want to get the x-coordinate of the first queen, we want to put L0, 0. If we want to get the y-coordinate of the first queen, we can put L0, 1. And then for the x-coordinate of the second queen, we can put L1, 0. And for its y-coordinate, we can put L1, 1, and so on. So let me just check that it works. And right, x-coordinate of the first queen, y-coordinate of the first queen, x-coordinate of the second queen, y-coordinate of the second queen. It's working perfectly. So now we want to actually check if any of these pairs violate these rules, since we have it all imported. And they will violate them if they share the same row, column, or diagonal. So we want to loop through this list. For queen, actually let's use an enumerate room. I queen 1 in L, and we can slice the last list again because we if we've checked it for the other 7 queens, it means that the 8th queen is completely fine. And now we want to get a second for loop. So for queen 2 in L, and we want to start at this index plus 1, and we want to end at the end. And now we want to compare the coordinates of the queens. We want to check if they're in the same row, column, or diagonal. So if they're in the same row, that means the x-coordinates are the same. So if queen 1, 0 is equal to queen 2, 0, and notice, what does queen 1 actually do here actually? Let's show you. So we want to print queen 1 and hashtag Python. Let's just print queen 1 to show you what queen 1 is. So if we run this code, queen 1 will, oh, sorry, I forgot to enumerate it. Let's go again. Queen 1 will return the coordinate pair of each queen in this list. So it's if we print the bigger list outside, print L. This is the bigger list, and queen 1 will be getting each smaller list inside this bigger list individually, looping through the entire list. And the same for queen 2. If we print queen 2 here, this will give us a very long output. So as we can see, it's looping through each individual queen after our first queen. So it goes 2, 3, 4, 5, 6, 7, 8. Reaching the end of the list, and then queen 1 changes to this, and then queen 2 becomes 3, 1 over here, 3, 1, 4, 7, 5, 2, 6, 8, and then it goes back here. When queen 1 becomes this, queen 2 becomes that, loops again, and so on. So we just now need to check if queen 1 and queen 2 are can threaten each other. And because we've already handled all of the looping over the queens and getting each queen. So if they can threaten each other if they share the same row, column, or diagonal. If they share the same row, their x-coordinates will be the same. And we can get their x-coordinates using the 0. If they share the same column, then their y-coordinates will be the same. So queen 1 equals 1 equals queen 2, 1. And if they share the same diagonal, this is where it gets interesting. So if they share the same diagonal, a very easy trick to figure out if they do is you want to compare the difference in their x positions and the difference in their y positions and get the absolute values. And if the absolute values are equal, that means they are on the same diagonal. Take this queen down here, C1, and this queen up here, E2. So this is 3, 1, and 5, 2. The difference in their x is 5 minus 3, which is 2. The difference in their y is 2 minus 1, which is 1. And the absolute value of 2 and the absolute value of 1 are not equal. Therefore, they are not on the same diagonal. If a queen was on the same diagonal as another, so say there was an imaginary queen here, let's just say there's a queen here, then the difference in their x-coordinates is 2, 5 minus 3. The difference in their y-coordinates is 2, 3 minus 1. And therefore, the absolute values of their differences are the same, so they're on the same diagonal. So how do we implement this? Let's get the absolute value of the difference in their x-coordinates. So that's abs queen 1, 0, minus queen 2, 0. And we want to check this is the difference in their x value. Now we want to check if the difference in their y value is equal to this. So this would be absolute value queen 1, 1 equals queen 2, 1. And if that's true, it means they're also able to threaten each other. Okay, that was a very long if statement, but now we can move on. So if they do threaten each other, this long line of code means it just checks if they threaten each other. In that case, we want to print yes. So we will print yes. And otherwise, well, if they don't threaten each other, we want to print no. So how are we going to do that? We're going to use a special condition of the for statement at the very end called else, like a else in an if statement. So all of this code in this else, so we'll print no here. All of this code here runs if the for loop executes perfectly. In other words, if the for loop is not broken. However, if the for loop is broken, then none of this will print. So therefore, we want to break the for loop up here. And if the for loop's broken, it will print yes and execute fine. Otherwise, it will print no. Now, let's just check if this works. So if we run this code, it should print no, just like that. But let's make some queens conflict with each other. So let's change these numbers so it's like 1, 1, 1, 1. This is more or less impossible anyway, but just as a hypothetical example. Ooh, okay. So we have a slight problem. And the problem is that this break statement only breaks this inner for loop, since we have two for loops. And we want to actually break the outer for loop. How do we do that? So in our case, we need to create a variable. Say, let's call this variable break queens threaten, and we'll set this one to false. Now, if we do get two queens that threaten each other, we want to print yes, so we want to set queens threaten to true here. Actually deviating from my original plan, but that's fine. Now finally, we want to check if the queens threaten or if they don't. And we can do that using a one-line if-else statement. So what that means is normally our if-else statements look something like if queens threaten, then print yes, otherwise else print no. But as I said, I want to make this code as efficient as possible. And right now, this takes us 7, 8, 9, 10. And honestly, we can do it in less lines than this. So a one-line if statement looks something like this. Print yes if queens threaten, else print no. And as you can see, it's like a rearranging of this statement, and it does the exact same job. So deleting those lines of code, this code now should work. So let's just test it for our case where there are queens threatening each other. And as you can see, the code works perfectly. Let's test it again for the case where the queens aren't threatening each other. And as you can see, the code also prints no. So we've solved 8 queens in less than 8 lines of code. So, ooh, what's wrong? Interesting. I've put true 1 there for some reason. Ooh, it's still printing no. Very interesting. I wonder why. Oh, this should be minus, not equals. And whoopsies, but just like that, our code is now working again. And we've solved 8 queens in less than 8 lines of code. So, onto the final problem of today. Bowling. In bowling, the player starts with 10 pins at the far end of a lane. The goal is to knock all the pins down. For this assignment, the number of pins and balls will vary. given the number of pins n and the number of balls k, followed by k pins of pairs of numbers, determine which pins remain standing. So the balls are numbered from 1 to n, and the subsequent pairs will for each k represent the first and last positions of the pins that were knocked down with each roll. Print a sequence of n characters where I represents a pin left standing and the dot represents a pin knocked down. Right. So let's import our numbers. Actually, we only need to import these first two numbers. So int s for s and input.split, that's all good. So remember, the first number here gives us the number of pins, and the second number here gives us the number of balls. So we want to also create an array that holds the number of pins, just as you can see here. And we also want to initialize this so that all of the pins are standing, so that they're all i's. How do we do that? Let's call our list pins, and we can simply say I for I in L0. So what this does is L0, this number here, gives us the number of pins, and in range L0. And therefore, we'll just loop over a range and put I in this pins array that many times. Now, we want to go for a for loop to get all of these other inputs. But the thing is, we don't know how many inputs there will be until it's told here in our first input. So we want to read this value and make a for loop that loops that many times. So for, let's say, roll ball in range L1. So L1 is this number, tells us how many balls are being rolled. And for each ball, we want to actually input these two numbers. So actually, we want for input dot split in range L1. So input dot split returns an array. So we can print. Actually, wait. We want to initialize. Actually, so for ball in range L1, and then we can say that the knocked pins is equal to the pins. Is equal to int I for I in input dot split. Right. Okay. And hold up, let me just plug in my computer. Okay. And for all of the numbers between these knock pins, we want to change the values here in their indexes from I to the dot. So for index in range, we want to start at the knock pins 0, actually -1. So the reason why it's -1 is because an array, a list, as you remember, starts at 0, but our bowling balls are numbered from 1 to n. So we actually want to subtract 1 from this number here, which gives the position when it's in 1 to n, to get the position in the list. So range knock pins 0 -1 to knock pins 1. We don't have to subtract 1 from this because if you remember, this is exclusive. And finally, we can set pins index to the dot. Finally, we want to print our output, which is simply our list of pins. So print pins. And that's all to the code. So let's run this code, copy and paste this, and as you can see, we get the correct output. So we've solved bowling in 7 lines of code, achieving our goal of solving all of the challenges today in under 10 lines of code. Let's just submit it to check if it works, and as you can see, it works perfectly. So that was the end of our list speedrun. Today was a bit longer because the challenges were a bit harder. And next time we'll be moving on to sets, I believe. We'll tackle some interesting challenges there. See you!